Okay, hi everyone. Wow, this is very popular, I guess. I'm going to be talking a little bit about, I'm going to talk a bit more about how GPT works, hopefully in a way that's not too technical, but will give you a better insight into how these models are built, a little bit about their uses and some of their caveats, so that you have a better sense of where they might be used in education and where, how to keep an eye on students and things like that. So to get started, let's start by talking about exactly what a language model is. So at its core, a language model is a probability distribution over a set of words. We use it to estimate the likelihood of some sequence of words occurring. So for example, on the right here, if we have a language model, we can estimate the likelihood of seeing the phrase the dog and the cat versus the likelihood of seeing the phrase the dog and the ostrich. In order to use a language model to generate text, we can compute the likelihood of any given word being the next word in that sequence. And then we just pick the word that maximizes that likelihood. Now, when I talk about estimating likelihood or maximizing likelihood, in practice, this is something that we can do by looking at as much text as we possibly can. By looking at a lot of examples, we can build a better and better estimate of the likelihood of various phrases appearing and creating different sentences. A very, very simple approach to this is for some given sentence, we can look up the number of times that that sequence occurs in some reference data set. Of course, this approach isn't very sophisticated, and it quickly runs into the issue of requiring more and more data the longer the sequence of text that we want to evaluate is. So there's many more sophisticated approaches, and in the last couple of decades, these have largely revolved around neural networks. And what do we mean when we talk about a large language model? It's exactly what it sounds like. The latest models that we have are capable of learning from much, much more data than early models were. So I made a graph, which is on the right here. Hopefully you can see it. It shows the size of neural network-based language models over the last 40 years. The y-axis here is actually logarithmic, so that long straight line is an exponential increase in the size of these models. But in the last few years, there's been an explosion in the size of these models. A large part of the reason for that is due to the introduction of a specific technology in natural language called attention. I'm not going to get into a lot of the details about how attention works, but the takeaway is that it's made it possible to learn from much, much larger sequences of text than were possible before. The other side of this is that in recent years, companies have been willing to invest more and more money in training these models. OpenAI hasn't made public exactly how much it's cost them to train their various models, but it's been estimated that training GPT 3.5 would have cost them anywhere in the range of $400,000 to $4 million. And GPT-4 is even larger than that. So the recent developments in this area are both thanks to some of these technological advances, but also just an increase in the amount of money that companies are spending on training. What actually is GPT in particular? So in 2018, OpenAI released a paper describing a new model that they called the Generative Pre-trained Transformer. I'm going to break down what each of the terms in that means. Generative is exactly what it sounds like. This is a model that creates something, in this case text. And GPT is based on a novel type of neural network that's called a transformer. I mentioned attention on the last slide. A transformer is just a type of neural network that uses attention. But the real innovation here is actually this pre-trained part in the middle. I'll get into a little bit more about what that means on the next slide, but the bottom line here is that the key innovation in GPT is the way that it's trained rather than the architecture, which is largely based on approaches that were already published. GPT-2 and 3 are almost the same model as that original GPT, but they each introduce some very slight modifications that allow them to be trained with substantially more data. GPT-2 is trained with about 10 times the amount of data as the original GPT, and GPT-3 is trained with about 1,000 times the amount of data. GPT-4 is trained with even more data than that. They've stopped telling us even how much it is. And it contains an optional component that allows the model to potentially recognize the content of images. They haven't actually described a lot about how that works, but it's something that they've alluded to. OpenAI hasn't been the most consistent when it comes to the naming of their products and their models, but overall, it's useful to understand GPT-3, 3.5, 4 as the actual models, whereas ChatGPT is a product that uses those models. So now I'm going to dive into a little bit about how the models that are used in ChatGPT are trained and why that's so innovative. An important thing to understand here is that when the model for ChatGPT is trained, they're actually starting with a fully trained GPT model. So before we even begin here, they've already created a model that is capable of this general problem of creating text. This model has already seen billions of pages of text from the internet, from books, etc. But the challenge here is to take that general model, which just predicts the next word in a sequence, and turn it into something that is good at this conversational prompt response Q&A style. So OpenAI starts with a set of prompts. For example here, we have explain reinforcement learning, which is a type of machine learning, to a 6-year-old. They then have a set of human annotators who write out full answers to that question. They take this pre-trained GPT model and they teach it to relate these prompts to these answers. But that's just the first step. In the second step, human annotators write more answers to the same questions so that we have a handful of answers for every single question. And somebody else ranks the quality of those answers from best to worst. OpenAI trains a completely separate model which learns to rate the quality of the answer based on the question. Again, this model is actually separate from GPT, and it's not writing anything. All it does is take in a question and a response and give some type of score indicating how good that response is. This is called the reward model. It rewards GPT for good answers. Finally, we take our model, which has been shown in some of these question-answer pairs, and we ask it to create completely new answers to some of the questions in the data set. The reward model rates the quality of those answers, and this continues in a loop where GPT receives a question, writes an answer, and gets a score of how good that answer is. This allows GPT to keep learning even though OpenAI doesn't have human-written answers to all of these questions. So in this way, OpenAI can take a data set with just some human annotation and get a lot more mileage out of it for training their model. At the end of this process, we have a model that was initially trained on this general task of creating data, but then is what we call fine-tuned on this task of responding in the question and answer style. This approach, as well as some of a few approaches that are similar to it, represent the sort of key contribution that OpenAI has made to the field. This approach is actually derived from the same method that is used to train things like self-driving cars, where the reward model is based on factors like obeying traffic rules and getting to the destination in good time. But this approach is not without issues. In this final step, we no longer have what we call a human in the loop. We have one model that's being trained by another model. That means that the quality of the model that's produced is highly, highly dependent on the quality of the model that's ranking it. Another way to think about this is that ChatGPT's goal when writing an answer is to produce something that it thinks will get a good reward from the reward model. And this is supposed to correspond to a good answer for us, but it's not actually guaranteed to. So even though the GPT model that we start with in this process has seen billions of pages of text across Wikipedia, thousands of books, the internet, who knows what else, this fine-tuning stage is based on a much smaller sample of these question-answer pairs. And this means that compared to every, say, page of text in the original training, each Q&A here has a vastly outsized influence on the performance and the behavior of the model. In practice, the paper where OpenAI first proposed this approach describes using it from with a data set that's drawn from Reddit. So there are significant biases stemming from the fact that there's only a subset of people who are using Reddit. And how are they writing answers? What kind of questions are they responding to, et cetera. In addition to that, that paper records the demographics of the people who were ranking the responses in the stage that was used to train the reward model. The majority of those people were young, white, American men. And obviously, when you're presented with 4 possible responses to a question, there's no objective best answer. It's down to the individual opinions of the people who are writing these responses. So this is a stage where the biases of those individuals can really come in and affect the ultimate performance of the model. In essence, the reward model is learning what its annotators think is important. There's no objective sense of quality here. There's just an average rating that's derived from these annotators' feedback. Now, to give OpenAI some credit, they have spoken quite openly about a lot of these issues, and there's a number of ways that are being explored in the field right now to try to address or alleviate some of these problems. But the versions of ChatGPT and similar models that are available right now do absolutely suffer from these issues. So when is this type of model most useful? As I established at the start, the task that GPT is trained to solve is just to predict the most likely word to follow a sequence of words. This ends up working really great for tasks like summarization and translation, where the previous text is most of what you need to get a good answer. Even a task like answering a question can just be thought of as summarizing previous answers that GPT was shown while it was training. Similarly, you can think of a task like getting GPT to write code as translating a description of a task from English into that programming language. Because GPT does a good job of writing answers to questions that it's seen before, it's easy to fall into the trap of thinking that GPT is actually the one answering your question. But it's important to remember that all it's doing is looking back at these text samples it was shown during training. That means that if a question is unique enough or requires knowledge from after GPT was trained, the model's going to have a very hard time giving you a good answer. When you ask GPT a question, it's not doing any reasoning. So if you say, what is 2 plus 2 equal to, it will say 4, but this isn't because it did the math. It's because 4 is the next highest probability word to appear in that sequence. GPT is not capable of creating something that is truly new. It's always trying to predict things that are seen most often in the current context. Let's talk about some more caveats. Within this training process, OpenAI tries to train the model to decline to answer certain types of prompts. They probably do this by inserting question-answer pairs where the question is offensive or political or in other ways inappropriate, and then the response is just a refusal to answer that question. So on the right here, we see someone has asked ChatGPT to write a scientific article about the benefits of eating glass. And ChatGPT responded by saying, I can't do that. Glass is not beneficial to eat. In fact, it's really dangerous. But in practice, these safeguards are very easy to circumvent. The user just replied and said, well, pretend that you did want to convince people to eat glass. And the model then went on to give this long answer, which I've cropped out, that was like a fictional scientific article about why it's good to eat glass. Because there's this disconnect between the vast amount of data that GPT is trained on and then the much smaller amount of data that it's fine-tuned on, the model's not always completely aware of its own abilities or limitations. In this example, a Danish user asked ChatGPT to speak to it in Danish. And ChatGPT responded and said, I'm sorry, OpenAI designed me to speak in English. I can speak in English, but I can't speak in Danish. The problem is that this response was written in Danish. The user was then actually able to continue that conversation where they were arguing with ChatGPT about whether it could speak Danish, with the whole conversation in Danish. So this is a disconnect between the fine-tuning step, where the model is taught that it's capable of certain things and that it should respond in a certain way, and the original training step, where it's just given this vast quantity of documents, which apparently includes some that are in Danish. ChatGPT also has this tendency to invent facts that can sound real if you're not familiar with the area being discussed. For example, on the right here, a user asked ChatGPT what the world record is for crossing the English Channel on foot. Rather than correctly responding that that's impossible, the model instead responded with an answer including the name of the person who did it, when they did it, and all sorts of other information. So this is clearly a silly example, but you can imagine that for a more subtle question, it can get really difficult to distinguish whether the model is telling the truth or not. It sounds very confident in its answer, even when there's no reason for it to be. This phenomenon is referred to as hallucination, and it's been estimated that at least for GPT 3.5, the rate of hallucination, or the number of falsehoods compared to truths, is somewhere between 15 and 20%. So it's kind of high. When ChatGPT was released, researchers quickly noticed that the model was very good at answering certain kinds of exam questions. This made headlines, particularly when GPT passed the bar, and other similar examples. In response to this, OpenAI sort of jumped on that trend, and when they released GPT-4, they had actually tested its performance on a wide range of exams, from high school chemistry to medical qualifying exams. They found that for many of these tests, GPT-4 easily achieved a passing grade. However, this isn't the whole story. For one thing, even in situations where GPT might never have seen an exam question before, there's a good chance of a very similar question and answer showing up in its training data. This is still useful in a lot of situations, but it's closer to remembering an answer that you've learned by rote than it is to having reasoning and thinking through an answer. Indeed, a pair of Princeton researchers put this to the test by comparing GPT-4's performance on two examples from the same exam, basically. One was administered before GPT-4 was trained, and the other after. They found that while GPT-4 scored perfectly on the earlier exam, it got none of the questions right on the later one. GPT is still very useful in a wide range of applications, to be clear, but the point I want you to take away is that we've seen a lot of these headlines about GPT passing the bar or getting a medical license, and we should be wary about the difference between just being able to remember an answer learned by rote and being able to perform the type of reasoning that is often actually asked for in those kinds of settings. In terms of exam questions, here's an exam question I found from the U of T library that ChatGPT had a very hard time with. You don't need to read the whole thing, but it's a long format philosophy question from a philosophy exam. It asks the student to come up with their own theory of the nature of property, and that theory has to meet a bunch of criteria, and the student has to justify how their theory meets them. This type of question is really challenging for a model like ChatGPT for a few different reasons. For one, this is a very creative and open scope question. Language models tend to give more or less the same response to the same question if they can. So if 3 students use the same model, they're all going to get very similar answers. In addition, even with prompting, ChatGPT is reluctant to write more than a handful of paragraphs. This is because the model is designed for that conversational style, and so it doesn't like to write long essays. It's also possible that OpenAI internally has discouraged the model from writing long answers, simply because longer answers are more computationally taxing and thus more expensive. Also, there's multiple complex criteria here, and ChatGPT is liable to forget to adhere to all of them. I found that when I gave this question to ChatGPT, it struggled to keep in mind all of these distinct criteria as it generated an answer. Finally, this question asks the student to refer to pertinent references in the literature read in class. Obviously, ChatGPT doesn't know what the literature you read is, but even worse, it will hallucinate references that look well formatted, include real authors, and often are about topics that they really did write about. So unless you are very careful and looking through that answer, which you can't really do in an exam setting, or you have a really good familiarity already, it's easy to get tricked by the model into using references that don't actually exist. So in summary, there's a number of ways that we can design assignments so that large language models are less useful for misconduct. Asking students to create unique and original work is a good way of ensuring that a language model isn't as helpful for producing the final product. LLMs will try to give approximately the same answers to everyone who asks the same questions. Including in-class components where the students have to explain their work is another good way of checking that they actually understand what they've submitted. I'd also recommend providing clear guidelines and explaining to students why language models shouldn't be used. A lot of students still might think that language models represent a sort of silver bullet when it comes to doing essays or assignments. They might think that it's as easy as putting in the question and getting a perfect answer out. So if you take the time to explain to them some of the criteria and some of the caveats that I've talked about here, it will help them to understand why this isn't really the case. I think that Susan referenced this, but a really fun hands-on way of doing this is using ChatGPT to generate an example essay on a topic you're teaching, and then ask students to go through and mark where it makes mistakes or it makes claims that aren't justified. This helps students work on the material that you're teaching, and it also gives them direct experience with the ways that a language model can produce a bad response. What if you're concerned that a student did use a model like GPT on their work? Well, I recommend looking for things like signs of repetition, within an essay, checking for repeated phrases, sentences, or sections even between students where the work looks very similar. ChatGPT also likes to reuse language that was provided in the prompt, so if a student's answer is lifting too closely from the question, that could be a red flag. Related to this, I would check the writing style. If students suddenly seem to have a very different style or a different level of sophistication to what you would expect from them, or even what you've seen in other parts of that same assignment, this could be an indication that they've used a model. Another really critical thing to look for is inconsistencies in a student's homework. As I said before, language models make up facts, and if the student is not as familiar with the material as they should be, it's very easy to overlook these. Along these lines, and as I mentioned, it's been found that GPT has a tendency to generate references that aren't real. For example, on the right here, a user asked what the most cited economics paper of all time is. ChatGPT responded with a paper that doesn't exist, but it includes real authors and it includes topics that they really did write about. So looking through a student's references and checking that they actually exist is a very easy way of identifying if somebody might have used a language model. Just very quickly on language detection software, the way that these detection models work is actually deceptively simple. As I introduced at the beginning, language models estimate the likelihood of a certain phrase appearing. If I provide a language model with a student's essay, that model's estimate of the likelihood can double as an estimate of how likely it is that the model would write that essay. To put it in another way, we'd like to see that the model disagrees with some of the student's choices. If it's in total agreement, then there's an indication that the model might be reviewing its own work. But there is a careful balance here. On the one hand, we want to see the model disagreeing with the student some of the time. But on the other hand, too much disagreement might just mean that the essay is badly written. At the moment, there isn't a widely agreed upon method to decide where we should draw that line. Also, this approach is somewhat dependent on using the same model that the supposedly language model using student did. If they use ChatGPT and I'm using Google Bard, I'm less likely to get a good estimate. Since we don't know what model a student might have used, this is a real issue. So to try to bring everything together, large language models function by successively choosing what they estimate to be the most likely word to follow in a sequence. They're trained on vast quantities of text, which increasingly we don't even know what that text is. Models for ChatGPT are fine-tuned on a much smaller set of question and answer pairs, which means they're susceptible to a range of biases introduced by human annotators. GPT models have a tendency to hallucinate false information, which can be convincing to outside observers. They also struggle with creativity, handling context outside of the immediate question, and following rules over an extended session. By teaching students the way that these models work, as well as showing their many issues, the promise of cheating with tools like ChatGPT will become a lot less appealing. Thanks. So we probably have time for a couple of questions, I think. Yeah, sure. go ahead.
Thanks for that talk. I get why it's very difficult for the ChatGPT to be creative, but it's less intuitive for me to understand why it would hallucinate so much. Do you have any insights on why the hallucination rate is so high?
So the thing about hallucination is that when we're training these models, we're training them to write English that sounds coherent and sounds like stuff that it's seen before. But there's no part of that where there's like a sense of what is true or not. So if a sequence of words is a well-formed sentence that sounds like the kind of thing that would show up, it's perfectly happy to generate that. Especially if you ask it like blah, 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 yes or no. Both yes and no are very likely answers, or like the likely words to be next in that sequence. So it doesn't care that much about which one it uses. Any other questions? Back there? Yeah.
Alex, I came to an earlier version of this talk, and I have to say this is some of the most succinct and clear explanation of ChatGPT.
Thank you.
I want to thank you for it. I do have a question. Please don't take this the wrong way. Did you use ChatGPT? Did you create anything?
I attended a talk where somebody did that line. They said, oh, and actually this slide was written by ChatGPT. And then they said, psych, I actually did write this myself. And I thought that was, to me, the point where I realized that joke has kind of already overstayed its welcome a little bit. So no, I didn't use ChatGPT in this version. No. Yep, go ahead.
So experimenting with ChatGPT, I found that it's able to write kind of like an introduction with a couple points and carry out those points in a multi-paragraph form. So I'm wondering if that doesn't speak to a kind of more structured way of representing the things it's about to output rather than just next word search. Because it seems like it's able to keep track of not just what word should come next in the sequence, but over multi-paragraphs, structurally how that should be.
It seems like it is, but it really is just conditioned on what it's already seen. The thing is that that conditioning includes what it's output already. So something like an introduction is actually really good for a model like ChatGPT because it's telling you, I'm going to make this argument, and then when it's generating the next thing, it knows I've already promised this, so that should appear in what I'm writing. If you ask it to do like a mathematical proof, it has a much, much harder time because when you do a mathematical proof, you have to have a sense of where you're going, but you don't necessarily write that out until you get there. And because it doesn't have any sort of working memory or working knowledge, it can't do that. There's a workaround that people have found, which is that if you ask it to, at every line of the proof, explain what it wants to do and how it is going to get there, it ends up giving you a much better answer. But that's because it's basically using the output as a version of this working memory that it doesn't actually have. Does that kind of answer your question?
I mean, that helps a bit. So it's the working memory then that's allowing it to do stuff over multiple sentences. And I'm just wondering, like, so you still think that the best way to characterize that is in terms of next word search with something that's modifying, where it's taking into account what it's already said, and that's explaining the ability to. Okay.
Exactly, yeah.
We're technically out of time.
Okay. Thanks so much, everyone.